Good morning, everyone. Thanks very much for joining us today. Our non-domestic, this is the first in a series of non-domestic webinars we're going to be holding over the next few months. This is domestic hot water systems in NEAP, and the object of this event is to provide the assessor with the knowledge of how to identify a hot water system and input correctly in NEAP, to establish the required efficiency data at the assigned storage aspects, whether individual or bivalent, and how to apply it to the zones. The presenter then will then bring the assessors through common errors and how to avoid them. Today we also have, at the end of this, we will also have some Q&A, and we'll run through that in a minute. Our presenter today is Brian Collatine. Brian is a partner at ORS and with a responsibility for energy management and fire safety teams. Brian specializes in supporting SEAI programs throughout, particularly the BER auditing scheme, where Brian is a non-domestic auditor. Today on our panel we have Antonella Uris. So we have from SEAI program team. Austin Rooney is from the help desk. Many of you will be very familiar with Austin and dealing with him on a daily basis. Aidan Brosnan, who is also an auditor on the BER scheme, and we have Murish O'Neill, who is with us from the help desk as well. Throughout the presentation, if you wish to put in a question, there's a little bubble down to your right hand side. You can click on that, enter in your question. We will try to get through some of them toward at the end of the webinar. Any of them that we don't get through, we will follow up with Q&A, and it will be sent out to all assessors within the coming weeks, along with a link to this webinar. So without further ado, I'll pass you over to Brian.
Hello, everybody. I'm presuming you can hear me, so if you can't, just holler. But thank you for the attendance today. Sorry about the technical issues, but we've that all sorted now. So our presentation today is on hot water systems, non-domestic webinar. As Stephen mentioned, I am a director with ORS, and I've been working on the BER auditing scheme for the last 10 years or so, along with Aidan Brosnan, who will be also sort of jumping in from time to time, more notably at the end for questions and answers. So just an overview of today, just to give you a sense, flavor of what we will cover. We'll touch on defaults, identifying hot water systems, seasonal efficiency, storage systems, secondary circulation. We'll touch on bivalent systems, which are rare enough in my experience, and but there is a facility for that, and we'll cover that in a bit of detail as well. Assigning the HWS to zones, and just common errors that we have come across generally. So before we move on with all of that, so what is hot water energy use? Well, the hot water energy use is a combination of hot water generation energy plus your storage losses plus your distribution losses. Your generation energy is dependent on your zone type, your zone area, and your generation type. Storage losses are from your cylinder or heat exchanger is generally in megajoules per month, but can also be done in insulation and storage volume as well. In terms of distribution losses, that's generally dead legs if greater than 3 meters, and hot water return loop length and hot water return losses. In particular, the return and loop length adds additional losses. So we'll touch on that throughout the presentation anyway. So firstly, we'll kick off with defaults. So when to assign a hot water system. Hot water system needs to be selected for each and every zone. So on the right-hand side, you see here it's 0.1965 liters per day per meter squared. So it's analyzing on a meter squared basis, based on the occupancy of the zone and the activity of the zone. it's dependent on the activity and the building type. It's not dependent on the number of toilets or anything like that. It's solely based on the occupancy. In fact, myself and Aidan were talking about this the other day, and we believe, don't quote us on this, but the toilet, for example, is taken in ISBM as 0 liters per day per meter squared. So the point being, it's dependent on the activity only and the number of occupants in that facility. And that's why you have to select it for each and every zone and some sort of hot water system. Also, any space with a dead leg within it needs to be associated with that appropriate system through the zone it serves. So when can defaults be used? Well, essentially where there's no evidence of hot water systems present, a hot water demand needs to be assumed, as I discussed in the previous slide. Evidence of hot water system present but cannot be accessed. So if it's not accessible, you need to take some form of default to run the program. Hot water storage system installation, if it's not accessible, there is defaults you can use from also for that. And all the defaults are outlined in A4.3 of the NEAP survey guide. So here's default example number 1, fairly straightforward. We have no evidence of hot water system present. So where no evidence of storage or secondary circulation losses present either. So here we have a grid. See on the left-hand side, we have instantaneous hot water only is your default from A4.3. In this instance, we're greater than 1998 in terms of years, so we've ticked that. Grid supplied electricity in this instance, we've used our default of 1 for electricity. And the important part on the right-hand side, tick if there's a system is a storage system, we leave that blank, and same for the secondary circulation. So we don't tick that, so it's assuming no storage system and no secondary circulation. So fairly straightforward. Moving on to the second default. This again, no evidence of hot water system, but where there's storage and secondary circulation losses present. So and can be identified on site. So where a fuel, oil, gas is supplied to the building, again, we have post 1999, so it's oil and gas in this instance, and the default from A4.3, as you can see in the picture there, is dedicated hot water boiler. We tick it because it's post 1998. We select natural gas in this instance for this building. It assumes the default. We don't change the default for this default system. We select storage system in this instance. We select factory insulated and 35 millimeters for post 99 build. And we talk about a bit where that comes from later on the slide generally, but that is the default from A4.3. We leave the storage volume blank and it'll assume its own volume because we have no information on that. And here we have secondary circulation identified, so we tick secondary circulation, and we've no details on circulation losses, pump power, or loop length, so we can leave them blank. So fairly straightforward there. Moving on to default example number 3. This is very similar to default example number 2, except here we have oil and gas is not supplied to the buildings. That's the only difference really. So from A4.3, it sets out a standalone water heater. Tick if the generator is later than 1998. Here we have grid supplied electricity. We have a default of 1 for electricity. We tick again that the storage system has a storage system, and we enter the defaults of factory insulation and 35 mil. And of course, we've identified secondary circulation, so we tick that in that instance as well. So in terms of identifying hot water systems, we'll discuss about a little bit about that. So dedicated, there's 6 types: dedicated hot water boiler, standalone water heater, instantaneous hot water only, instantaneous combi. We can select heat pump, and we have same as HVAC system, and we'll talk about each in detail now and the differences between them. So a dedicated hot water boiler. So a dedicated hot water boiler, as defined in SBEM, is a heat generator serving a separate hot water storage unit. It does not provide a space heating service. So you can see from the schematic, we have a separate boiler doing a thermal store, and hence that's serving the hot water, and there is no space heat demand whatsoever. Here it's similar to the previous, except it's all within one unit. So a standalone water heater, as defined by SBEM, is a unit that combines hot water storage and heat generator in one single unit. So everything's done in one single unit and your hot water is tapped off that. So on the left-hand side, you can see examples of that that are quite common. Your under sink heater, we'll discuss that later on, that should be entered as standalone water heater, as it has a storage capacity within it, and certainly the one in the middle has a storage capacity within it. So that's how that's entered. So instantaneous hot water is similar to the previous, except here we have limited or no storage capability. So the best example of this, if you imagine your electric shower at home, would be a good example of that. And you would come across that under sinks, for example, providing hot water from time to time. So an instantaneous hot water heater, as defined in SBEM, is a water heater with no or limited storage capability. The water heater instantly heats water as it flows through the generator and does not retain water internally, and it's only serving the hot water for that selection. So fairly straightforward. In terms of instantaneous combi, this is similar to the previous one, except the fact that it does the space heating load as well. So in that last example, it was only hot water. It is the space heating here as well. So an instantaneous combi heater, as defined in SBEM, is a space heating boiler that also provides domestic water heating with no or limited storage capability. Your next selection is heat pump under HWS, so you can select that. So a heat pump, as defined in SBEM, is a heat pump providing only domestic water heating service. So here on the left-hand side, you can see an example of a system. Fairly straightforward. You have your heat pump serving your heat exchanger and pumping off that for your hot water throughout the building. Then lastly, there's same as HVAC system. We would have all came across this option. This option is chosen that the hot water provided by the existing HVAC system serving the space heating load. So here we have a boiler system doing a space heating load, and that also does the hot water. So same as HVAC, just really saves us entering the detail again, and I'll take the information you've selected for the HVAC system. So fairly straightforward in that event. Documentation evidence required for that. So for non-default HWS entries, we need obviously photographs of HWS plant, technical data sheet, as-built drawings, and for new provisional BERs, we would need design drawings and specifications to identify that. So on the right-hand side there, you have your typical specification, giving you information in relation to a particular unit, which you can use within your audit or BER. Moving on to seasonal efficiency. So effective heat generator seasonal efficiency. So default values should only be used if it's not possible to obtain the HW plant efficiency data. So if you can get any data on site, it's far better off to use that information if it meets the below requirements. So non-default efficiencies may be obtained from the following sources. So CE mark literature from the manufacturer referencing the efficiency, accredited test certificates, or the ECA or ACA websites. So here on the right-hand side, just a demonstration of efficiency, a gross efficiency for a standalone gas-fired hot water heater. So that could be used as non-default efficiencies. Seasonal efficiency of heat pumps. So this is an important point. Where a heat pump is used for the water heating, the assessor must select heat pump as a generator type and cannot select same as HVAC system. So for heat pump systems, you cannot select same as HVAC system. Where a heat pump is compliant with the Eco Design and Energy Labeling Directive, the water heating energy efficiency is taken directly from the Eco Design certificate. And you use that by multiplying by 2.5 and divided by 100, and you can enter that value into ISBEM. So here on last point, we have an example. We've been given 120% from the Energy Label Eco Design certificate, and we've converted that by multiplying it by 2.5 and dividing by 100, which gives you 3. And obviously, if we have insufficient documentation evidence, a default can be used. And I checked ISBM, and it seems to be 1.5. So you can see there's a big difference from using the default to actual data. Storage systems. So the assessor must determine that the HW system has a storage system. It's more accurate for obvious reasons. The most accurate way of entering it is storage losses in megajoules per month if you have that data. If that's unknown, the storage volume, insulation type, and thickness can be entered, certainly. But obviously, if you've no value, if no value is entered, you can use defaults. So on the right-hand side, you see a typical system. Generally, there'll be a label of some description on it that you can use in terms of megajoules per month, generally. But where storage volume is not available from other sources, estimate the storage volume by measuring the dimensions of the storage vessel on site. So that would be common enough in terms of practice out there. And if insulation is accessible, estimate the insulation depth by measuring its thickness, using a pin, for example, or other method. But if you can make some estimation on the insulation thickness. Alternatively, the default hot water cylinder insulation thickness can be used, and you would base that on the year of build generally. So hot water storage insulation, if not accessible. So these are the defaults in terms of insulation thickness. Insulation thickness is based on the age of the storage unit as below. So pre-1994 is no insulation. 94 to 1999 is 25 millimeter.
Hi there, we seem to have lost connection with Brian. Would one of the other panelists mind taking over the presentation there for a moment while Brian tries to reconnect? Apologies for this issue. Brian, if you can hear us, if you try and log out and log in again there, and we'll ask one of our other colleagues to take over. Thanks so much.
Just pass you on to Aidan there.
Yeah. Oh, Aidan, you're a presenter there.
Live now. It's fine. So Brian was going through the installation thicknesses there. So there's guidance in the NEAP survey guide by age for the default efficiencies, and generally it's done on building age, but there is just a helpful thing whereby CE marked heaters can be assumed to have an insulation of 25 millimeters. And that's because the CE marking came in after 1994. So if you see a CE mark in heaters post 1994, so that's helpful to fit your rating if you have a lot of age. So if insulation is accessible, you can look at the label on the unit and try obviously look it up, and then look up the manufacturer's data online. So if you can't obtain reasonable data on storage capacity of the unit, you should measure the unit on site, but just take account of the insulation thickness when you're doing so. So there is some guidance in the survey guide to measure up. So I'll be in a slightly later slide. Obviously, defaults are a last resort if you maybe if the cylinder is accessible or something like that. So to measure the cylinder, there is this table available in the survey guide. So you can you measure the cylinder without the insulation, subtract the insulation, and you can use this table to look up the storage volume. So this table has precedence over calculating the volume using pi. The capacities are between 71 and 41, you might say. They're the streams of the covered on this. So use this table first, and if your cylinder is bigger, it's your you might have learned in school pi to
Hi, Aidan. Sorry to interrupt you there. Just there's a few people commenting that they're finding it difficult to hear you. So would you mind just testing out unplugging your headset and just trying with the mic from the laptop itself, just to see if that improves the sound? Thanks so much.
Is that better for anyone?
That's much better, much better. Thank you.
Okay. I only got that yesterday, so that might need a bit of tweaking. I'll keep going anyway. So look, this is just an example there where the cylinder is measured and the diameter is 500 and the height was 1100, and the guidance in Appendix 9 said you should look up the nearest diameter. So in this case, it's 500 by 1200. So the volume is 190 liters. So that's just giving an example of how you would use that table. So this is just, we said that calculation from school about calculating the volume of a cylinder if you are, you might say, if you're running off that table. And of course, not all hot water cylinders are circular. There's also these under-sink heaters. Now, they normally will have a sticker on them. In my experience, they're usually 10 liters. They're usually called something 10 or something 20. Brian might be back now.
Yeah.
But this is just the calculation for those. I'll let Brian carry on now with the presentation.
Perfect. Sorry about that. I don't know what happened there, to be honest. That never generally happens. So I presume Aidan has covered down to here, so I just keep covering from here. So here we have a cuboid opposed to a cylinder setup. So here it's height by depth by width. The important thing is to take off the insulation thickness from when it's a cuboid as well in your calculation, and you multiply that by 1,000 to bring that back to liters. So here's an example, a water heater 550 by 330 by 330. We have it installed, presumed 2005. So we're assuming a 35 millimeter default in terms of installation. So here we have height by depth by width multiplied by 1,000. So we take our 70, which is insulation on both sides, from the 550 to get 480, 260, and 260. So the volume here is 0.48 by 0.26 by 0.26 multiplied by 1,000. which is 32 litres. And that's in the Appendix 9 of the NEAP survey guide. So it's easily accessible if you come across them generally a cuboid. As I said earlier, standalone losses, storage losses are ideally to be identified as megajoules per month is the best way. This may be available for manufacturers. However, manufacturers are more likely to quote the losses as kilowatt hours or watts per 24-hour period. So here on the right-hand side, as you can see, we have 86 watts, and that's the loss per 24-hour period. So I suppose the important point is that 1 kilowatt hour is equal to 3.6 megajoules. And you can take that, and depending on what value you're given, you can use that calculation to convert back to megajoules per month, which we'll go through now. So here we have 86 watts identified. We multiply that by 24 hours and divide that by 1,000 just to bring it back into kilowatt hours. So here's a specific example which shows a manufacturer quoting the cylinder losses at 2.064 kilowatt hours for a 24-hour period. So that's just 86 watts referenced on the other side. So using the relationship 1 kilowatt hour equals 3.6 megajoules, that converts to a relationship of 2.064 kilowatt hours to 7.4304 megajoules. So megajoules per month is simply, you take that figure down below in red and multiply by 30, and that equates to 222.9 megajoules per month. This procedure should be used for each individual storage cylinder identified in the assessment. So each cylinder must be accounted for in this method as well. So where you have multiple HW systems on site, there's 3 options available to you. So the first one is where you have clear independent parts, which generally happens in most situations. So on the right-hand side, you have a building, say, where the blue and red area zones are completely served by completely independent parts, and that can be identified quite easily on site, and you just input it according to that in its independent parts. Option 2 is where there's 2 or more HWS systems where they're serving zones simultaneously. So for here, the HW system with the majority of the hot water demand is taken as your HWS. Option 3 is similar to option 2, but where a combination of HWS generators serve the same zones but do not work simultaneously, such as a backup generator, for example. One is selected, and i.e. not the backup generally. You would presume the main system. And just an MB, as mentioned on previous slides, the storage capacity should account for all storage in its entirety. Again, documentation evidence required can be met by one of the following: photographs, technical data sheets, generally from O&M manuals, as-built drawings and specifications, design drawings, particularly for new provisional BERs, and hot water storage volume measured on site, which is common enough as well. So secondary circulation. So what is secondary circulation? That's just a schematic generally to give a sense of it. But basically, it's where there's a return on your hot water coming back to your cylinder. What is it for? I suppose to have hot water at the taps, but it was also introduced to eliminate or reduce Legionella disease as well. Very identifiable on site. You would see it in the plant room generally. A hot water return pump generally is on the return side, and generally they're labeled anyway. You'd also see it in the bathroom itself. You might see it under the sink, where you can see the hot water tap coming to the sink, and generally about 300 mil away from that there'll be a return identifiable. So it's easily identifiable on site if you look for it. So obviously the assessor must ascertain if the HW system has a secondary circulation. So if it does, on the right hand side here, you can see we can we can enter it by just ticking the secondary circulation box. And we can leave the circulation losses, pump power and loop length blank if we don't know that information, and it'll assume defaults. And if you run the ISBEM model, it'll identify what them defaults it's assuming is. If no values are entered, ISBEM use defaults. The assessor should use defaults when the inputs cannot be determined for obvious reasons. And just for clarity, you can leave. You can enter 2 values and leave 1 blank. For example, it will still run. The pump power kilowatts can be found in the pump nameplate or the manufacturer's data sheet. So that pump on the return side of the secondary circulation can be entered into the program for accuracy. MB, the secondary circulation pipework length refers to all the pipework, i.e. the flow and return. Just one to bear in mind. So here we have secondary circulation losses calculation. So the table below gives indicative thickness of insulation for non-domestic hot water services. So down below you see the table, which is sourced from Part L. And we'll talk about, just go through one example to give you a sense of how to enter that or calculate that. So essentially we're calculating the average heat loss in watts per meter. So for example, secondary circulation installed with the following pipe lengths and heat loss. So we have a 100mm pipe. We calculate a 7.2 millimeter diameter, and as you can see in the right hand side, that equates to 6.6 watts per meter loss. We also have 50 meters of pipe work at 33.7 millimeters diameter, which equates to 8.62 watts per meter from the table. And finally, we have 10 meters of pipe with 76.1 millimeters diameter, and that equates to 13.09 watts per meter. So when we have them each individual loss elements, we use an average weighted calculation, which is down below, which is 100 multiplied by 6.6, 50 by 8.62, 10 multiplied by 13.09, and that's all divided by the total length, which is 160. And that equates to 7.64 watts per meter. So that gives you an idea of how to calculate that, where you have all the information to make that assessment. The documentation evidence required for these inputs can be met by one of the following, which is a similar theme for other inputs: photographs, technical data sheets from O&M manuals, as-built drawings, design drawings where you have new provisional BERs, and heat losses from pipework in compliance with relevant standards where applicable. So moving on to bivalent systems. As I said at the start, these are quite rare. You don't come across them too much. Certainly you come across them in HVAC systems, all right. A number of bivalent systems. For hot water, not so much, but there is a facility there for it. So the subtab, this facility or subtab comes active only if the generator type in the general subtab is not defined as same as HVAC system. So for all other inputs, it will give you the option to enter a bivalent system for hot water. So a bivalent water heating system is a system in which the heating is supplied by 2 or more different types of heat sources, similar to a bivalent HVAC system. And as you can see on the right hand side, that it'll come operational there, the tab up high there. So when you click that, for each additional heat generator, the following parameters need to be inputted. So generator type, fuel type, and effective heat generator seasonal efficiency, and the proportion. So if unable to determine the load profile, there is a default which is 50-50. It can be assumed, but you might be able to make an assessment of the load profile. But if in doubt, you can always use the default. So we'll go through a quick example here. So here we have a dedicated hot water boiler and an instantaneous water heater. So we define the dedicated hot water boiler system in the normal way. So you can see on the right-hand side, we have dedicated hot water boiler. In this instance, we're greater than 1998. So we've assumed natural gas in this instance, and we're using the default. So that's the main system as such. And then your bivalent is an instantaneous hot water only, grid supplied electricity, efficiency of 1, obviously for electricity. And in this instance, we don't know the proportional load, so we've assumed the default of 50-50. And so we added in there 50% there. Assigning the HWS to zones. So assigning the HWS to zones, the HWS defined is assigned to the zones it serves under the zones tabs and the HVAC and HW system sub-tab within the building services form. So you open up the building services form, you put the under HVAC, you'll have 2 entries for hot water system, which you can select accordingly based on what systems you defined. So again, this is required for all zones, and it assumes a hot water load for all occupied zones within ISBEM. And also there's an entry for deadleg length for each zone as well, which I'll talk a bit about on the following slide. So deadleg length. So the deadleg length affects where the deadleg is more than 3 meters or above. It doesn't take into account when it's less than 3 meters, just for information purposes. The length of draw off pipe to the outlet in the space is essentially the deadleg. This parameter is used to determine the additional volume of water to be heated because the cold water in the deadleg has to be drawn off. So anything above 3 meters, there will be an additional load, although very, very minor. It's measured from the edge of the zone or to the outlet point. So from the edge of the zone to the outlet is generally measured, is your measurement you take. And where pipe work is not visible, you can just take from the edges of the zone. You can take an estimate basically from the edge of the zone to the outlet pipe in a direct route fashion. So common errors. We covered most items that crop up on the previous slides. So these are fairly straightforward, but do crop up surprisingly quite regularly. So here we have the insulation. In this instance, the insulation thickness was taken as 25 mil. We have a 2004 building, and the age of the storage unit is unknown. So we're taking the age of the building, and as it's post 99, it should be entered as factory insulated 35 mil, and volume left blank because we have no information on the volume. The assessor has inputted here factory insulated 25 millimeters. It does come up from time to time. I don't really know why. It might be a file save as issue, or it's just an input error, but it does seem to come up quite often as a mistake. Another one is the electric storage water heater. So under sink electric water heaters are commonly selected as instantaneous water heaters. Instantaneous hot water heaters are defined in SBEM as having no or limited storage capability. So on the right hand side, we see a typical standalone water heater. If you look at the label on that, it will have a storage capacity on it of 10 liters or 15 liters generally, and sometimes 25 liters. But these should be entered as storage standalone water heater with a storage system ticked and the appropriate information entered into it, such as the 15 liters or 25 liters, whatever is associated with that. So thanks very much. Apologies for the break in between, but these things happen. Moving on to questions, I think. I think the host can come in.
Yeah, just going through, actually, there's very few questions in. I think there was one question in there that was answered.
Yeah, I think
by-
Aidan has covered a lot of
Aidan.
them.
And now there's one or two there. There's one there for you, Brian. Does secondary circulation pipe length include the dead legs to the taps or just the loop?
The secondary dead legs to the taps or just the loop? Generally, I've seen it's the flow and return. So the dead leg would be entered independently. So the dead leg, it wouldn't include the dead leg. So the flow and return and the dead leg would be separate. Is my interpretation of it, but I'd love to get Aidan's view on that as well. I believe that's the way it is on ISPM. Would you agree with that, Aidan?
Sorry, Brian, it's Austin here, and
Austin.
yeah, your interpretation is correct. It's just the loop.
Yeah,
Perfect.
that's right. Yeah.
Okay, and if another question here, if you cannot see all the pipe work and existing, do you have to use the default, even if the pipe work you can see has been lagged?
I was just starting to type
Sorry, Aidan, your
an answer for that.
yeah, your sound is very poor,
Yeah.
Aidan. So I think from what you're saying, you're just starting to type an answer to that. So we can type that in if anybody
If
else.
I think what we're
Sorry.
trying to say, we can identify some of it, but not all of it.
That's what
Yeah.
I was typing.
Yeah, let's type.
Yeah. Can you hear me okay?
Yeah, we have you there. Yeah. No, I think we're going to be on a
Might
loss
answer
leader
it.
there today. Yeah, do you
Yeah,
want to
we might
answer it
answer
there, Brian?
that. Yeah, we might answer that separately, Stephen.
Separately?
Just we'll,
No problem.
we'll confirm it, but my understanding, it depends on the information you have. Like, I mean, if there's certainty and amount of certainty in it, I would say it's okay. But where you're in doubt, you should really be going to the default if it's. But it depends on the amount of information you can determine, I suppose.
Just want to hear, how do I enter a heat pump efficiency for a heat pump that supplies space and water heating?
Yeah, that was covered under the slide, so you have to enter them separately. You can't use same as HVAC system as such.
Okay, that's grand. Just another one here. What storage volume does limited equate to in relation to instantaneous hot water systems? Now, granted, some of these may not just be, even though they're one-line questions, they may require more input as well from QA. So I'm just conscious of any of these I'm reading out. If you feel it requires to go into the PDF, you can just let me know.
Yeah, I don't think that actual value, and I've looked for that myself. There's no actual value as such as limited, or is defined in the NEAP survey guide. But in practice, anyway, anything from 5 liters and above would be entered as standalone water heater.
Okay.
Yeah, the word limited hasn't been defined properly by the department. So yeah, 5 degrees above is reasonable.
Okay, let me see. There's a couple of them there in software. We're going to have to come back to them with in our follow-up PDF. Where there is one small hot water heater in a building, say for example, under sink heater in a small toilet, but the overall building is quite large, many zones. Should the small heater be used as a hot water source for all the zones within the building?
Yes, should be. It may not be enough hot water in reality to serve the occupants, but look, that's what it is. So hot water, as Brian covered in his slides, hot water energy, you've an amount goes to storage and you've an amount of generation. So the storage will be the casing losses of that 10-litre under sink heater, which you will go in by entering the 10-litre volume and the 25mm insulation. So that's gone in. And then the generation losses are based on heating water using electricity to suit the number of people per square meter, which are defined in each zone type. So you would, while officially no hot water gets used in the toilet, in the adjacent open plan office, we'll say it knows there's so many people per square meter. It knows that each of these people, because it's an office environment, uses so much hot water, and it's calculated from there. If the zone were accident and emergency or a nursing home, the consumption per square meter will be greater. So remember you have storage losses, which are to do with the size of the storage vessel and the insulation, and then you have generation losses, which are to do with the efficiency of the generator and the type of zone, the amount of water being drawn off.
Question here on a heat pump. Usually if the heat pump supplies a space heating, it won't have the EN 16147 data. So are you forced to use default in that case?
I don't know that one off the top of my head. To be honest, I'd have to look it up.
It would be unfortunately, yeah.
Follow up.
Yeah, so I believe there is it's mandatory to publish that information on their eco design for all water heaters. So for all heat pump water heaters, so that information should be available on the eco design.
So, and Austin, were you looking to add to that?
Sorry,
No,
is that...
yeah, I suppose in the absence of the 16147 data, then a default is used. Yeah. But as Angela quite rightly said, suppliers should be providing 16147 data when the heat pump is supplying the hot water.
Okay. One more here. Disabled toilets with a shower. In reality, the shower isn't used frequently. Should it still be entered as a changing area?
No, I wouldn't recommend you do that, because particularly in the new release of ISBM, the amount of hot water used in changing areas is very large. So the shower and disabled toilets is usually intended just for occasional use. So it wouldn't be an accurate representation to classify it as a changing area. Equally too, watch out for things like food preparation. If you just have somewhere where people make cups of tea and eat sandwiches, just be careful not that you haven't entered that as a sort of commercial kitchen. Again, you'll have a higher hot water, much higher hot water usage in a catering type kitchen than you would just where people are boiling kettles like a staff room or something like that. So just what those two are worth looking out for. Yeah.
Okay. Using this one here, using the example of an under sink heater that is serving one room, but is located outside the room, e.g. a toilet, from the as-built drawings and measurement on site, you know that the length of the pipe work from the water heater to the outlet. Which deadleg length is correct? From water heater from outlet or from edge of zone to the outlet?
It's the edge of zone to outlet. Is the deadleg. Agree with that, Ian?
Yeah, the manual's not the user guide is not entirely clear, I suppose, because it when it speaks about deadleg, it assumes the deadleg commences from the edge of the zone where it says the secondary circulation loop is, but if you've no secondary circulation loop, what happens then? It's not 100% clear. The thing is with secondary circulation, particularly in healthcare, like in Ireland, I think that the HSE would specify a meter of a dead leg from the loop for avoidance of Legionella. So in most cases where you've a hot water loop, you'll be well within your dead leg would be very small. But yeah, it's not entirely clear where if I were doing it just to be safe, I'd probably include the full length just to get it in to the software. But a dead leg only becomes active when it reaches 3 meters in length. It adds 16%, I think it is. It's in the technical manual if anyone wants to look it up. It adds 16% onto the hot water generation losses in that zone. So if you enter a dead leg of 2.5 meters, it won't actually do anything. So
Okay.
dead legs.
Just yeah, there was another follow-up on the test data for certain systems. It's not possible to source the EN 16147 data, so you're not going to get a true reflection by using defaults. Yeah, I mean that's always the case anyway. Defaults by their nature are pessimistic. If you don't have the data, well, you're not going to have the true reflection of the system. So the defaults are there, applicable to what system is in place. But yes, like I mean, by their nature, it isn't always the 100% true reflection of it. I think we're all aware of that. Just one, where dead legs are less than 3 meters, is it okay to not enter in ISBN?
Well, they won't. If they're less than 3 meters, they won't make any difference. So, in my view, they can be omitted because they won't do anything. I've experimented with it just to try it out. It's useful actually. I say this to assessors. It can be useful just to get a one zone model. When in SBEM, there's folders in the SBEM. If you just go rooting around in where your SBEM files are, there's a folder in there where there's a couple of pre-made SBEM files, and one of them is one zone. And it can be handy just to save that somewhere and have a one zone model just to play around with, just to try stuff out, because it runs fierce quickly. And you can just change something in one zone and see what difference it makes. That's my tip for the day.
Okay. If there is no outlet, if there is no outlet in a zone, how is the dead leg measured?
If there's no outlet in the zone,
How
it'll
is the
be
dead leg measured?
generally be going to an outlet.
Yeah. Okay. So like if the assessor can give a bit more information on that, where they're coming from, that
there's no outlet in his zone. Oh, maybe he's sort of suggesting that goes through another zone as well, possibly. And
yeah, look, if they need further clarification on it, please send it into the help desk. That seems to be it. There are a few in there, like I said, which will require a bit more in-depth information. We'll put that in the PDF that we will be sending out. That hopefully will go out over the next week or two, along with the links for the webinar and slides and that. So that will be happening. Assessors will be notified of it. There's just one more there. Will the treatment of district heating networks in NEAP be similar to DEEP? Well, again, I think that's a question for a PDF there. So we can follow up on that as well. So Brian, Aidan, Austin, Antonella, unless you have any more to add in here, I think I think we're there at the moment. There's just one here. I'll just read it out to you, try and get a final one in. If you have two different hot water systems that supply different zones, i.e. different floors, do you assign hot water to the zone or use the multi-hot water calculation with split 50-50 if not known?
To me, that was the first option on the slides early on. So that would be, you would select a HWS for the first floor and the separate HWS for the ground floor.
Yeah, in that instance, the assessor creates two different hot water systems and assign it to each zone that the system is assigned to. Same as Brian's slide there with the red box and the blue extension.
Box, yeah.
Okay. There are a few questions. Sorry, go on, Aidan.
I was just going to say, if you enter them as two separate systems, you'll get the storage volume gone in, and then assign them as best you can then to the zones that you think they serve. But you'll be as long as you get the two storage volumes in and the insulation in, assign them as best you can, you'll be pretty close. You do your best on it. If the two happen to have the same fuel, same as LTHW, or or they're both electric, then it's fine because the efficiencies will be the same, and you'll have entered the two storage volumes. You'll have got the standing losses. So most of the time it's not a big deal. But I know occasionally you can get buildings that were extended all over the place, and yeah, it can be kind of tricky. But you do your best to assign them.
One more there again on dead legs. Does the 3 meter limit apply to total dead length or individual, i.e. you have multiple taps in an area?
It's the dead leg in the zone, so it would be the summation of the dead legs in the zone, I would say.
Yeah, it would be total dead leg length
length
in the zone. So it would include all the multiple taps.
There's a few questions in there with regard to EN 16147 on test certs and that. We can come back to you guys on that. And I just want to make a note as well. Yes, there are a number of questions there relating to individual guidance that individuals may have received from the help desk, so we will follow up on them as well. Okay, so I think that's it for today. So I'd like to thank Brian Collentine and all our panel, and we do apologize for all the technical issues we had there at the beginning. It was just one of those days, and we will follow up with further questions, answers, sorry, to these questions. And if you do have, as always, any other questions that you want to send in or get answered, please forward them into the help desk. And our next presentation in the series, then Aidan will be giving us knowing your work. So we will be sending out invites and information with regards to that as well. So thank you very much for joining us, and thanks to all the panel.
Thanks, Stephen.
Thanks, Stephen.